Hi, I'm Tom Loschiavo, Education Manager here at PASCO Scientific.
And I'm Barbara Puglisi, Curriculum and Training Specialist at PASCO.
And we're here today to talk about the wireless conductivity sensor. So right out of the box, this sensor is ready to use. There are no additional wires or cables to get in the way of your students doing experiments. So all you have to do is take off the little sensor protector, and it is ready to go.
We're going to connect the sensor in the software, but before I do that, we have to turn the sensor on by pushing the power button.
So you'll notice the red battery light indicated for a second. This does come with a coin cell battery, and it should last typical use for about a year. If that red light stays on, then you know it's time to change the battery. And
when I turn the sensor on, I can see that the Bluetooth light is flashing red. That tells me that the sensor is ready to connect in the software.
So now I'm going to go to my software, and I'm going to pair it using the Bluetooth icon. So I'm going to touch on the Bluetooth icon, and I'm going to see that sensor in my available devices. If I had a room full of these with students, they would all appear there, but the one that is closest to your device will be on the top of the list, and that's great for classroom management. So I'm going to touch on conductivity. Now it is in the connected devices section of the screen, and I'm going to hit done.
And if I look at the sensor, the Bluetooth light is now flashing green, and that indicates to me that the sensor is connected.
Right, so now it's connected via BLE, and I see the sensor measurements pop up on the home screen. And I can see that this conductivity sensor can measure conductivity in microsiemens per centimeter. It also measures total dissolved solids, or TDS, which are great for water quality, and it can measure those in milligrams per liter. It also has built-in temperature compensation in the probe, so you can do your water quality samples without worrying about temperature fluctuations affecting your measurements.
The sensor is also water resistant, so it's easy to use with an experiment like this where we're going to be testing the conductivity of several different solutions.
Okay. So since we're going to test several different solutions, we're going to set up the software to measure in a bar graph so we can categorize each of those solutions. So I'm going to go into SparkView, and I'm going to touch on Build, and I'm going to touch the big template. So I want to see the big graph, and I'm going to touch on bar graph. And now I want to make sure I'm using conductivity on the y-axis, because I am going to measure the conductivity of those samples. And since I'm in a bar graph, it automatically sets it up to manual sampling. So how do we get the sensor ready?
Well, it's always a good practice to clean the sensor before you use it with distilled water. Just rinse the probe. And don't forget to get inside.
And it's a good thing it is water resistant, because you will be rinsing it and students will be squirting liquids around. Hopefully not too much.
First we're going to test distilled water.
So now I'm going to go to my software, and I'm going to set this up so I can see display a little better. I'm going to turn off this predictive bar. I'm going to turn on, in my bar graph tools, the numbers over the bars, so that the students will be able to see the bars fluctuating and the numbers on top. And I'm going to start my data collection. And now we can see bar 1 for that distilled water is reading 0.
0. Yeah, and I would expect that. It's distilled water, so it should have a low conductivity.
So now that the number is stable, I'm going to hit Keep before I move on to my next measurement. And I'm going to rename this bar distilled water. So what are we going to test next?
Well, first I'm going to rinse the sensor, because it's good to rinse with distilled water in between samples. And then we're going to measure the conductivity of a sports drink.
I hear there are electrolytes in them.
Let's find out what electrolytes are. So here's the conductivity of that sports drink.
Wow, that is a big jump.
That's over 2,000.
Yes. So I'm going to hit Keep in the software again. And I'm going to go rename that bar sports drink. And then we'll get our next sample ready.
So while Tom renames that bar, I'm going to rinse the sensor, prepare it for the next sample. But what I'm really curious about is what's causing the conductivity in this sports drink. Because if I look at the ingredients on the label, it says water, several different sugars, and several different salts. So what is causing the conductivity? We know it's not the water, because water read a conductivity of 0. So it's either the sugar or the salt. Now I've got a sugar water solution here and a salt water solution here. Let's begin with the sugar water.
Yes. Oh, a little fluctuation there, but it went back down right around 0.
Okay, that's pretty similar to distilled water.
I'm going to hit keep, and I'm going to rename that.
And I'm going to clean the sensor. Are we ready for salt?
We are ready.
Okay. And here's the salt water.
Wow.
Wow, that's over 12,000.
That is a huge jump. So I'm going to hit keep.
So how high can the sensor read?
That is a great question. So the sensor can read up to 20,000 microsiemens per centimeter when you're looking at conductivity. So if you do have a sample that is reading higher than that, 20,000 or higher, then you might want to dilute your sample so that you get a more accurate representation of what's going on. So I'm going to rename this bar after I hit keep to salt water.
And I'm going to clean the sensor before I put it away for storage. And I would also like to dry it off before I put it away. So looking at our data, Tom, what do you think caused the conductivity in the sports drink?
Well, it definitely was not the sugar, because that did not change the conductivity. But that salt really did change conductivity.
Yeah, that's right, because when you put sugar into solution in water, sugar compound does not split apart and form ions because it's covalent. But when you put salt into solution, salt does split apart into separate ions, and those charged particles conduct electricity, as we measured with our conductivity tester.
We can definitely see that with the data.
Right.
So we were able to do a very simple, easy experiment with this wireless conductivity sensor right out of the box. For more ideas of experiments that you could conduct with this sensor, please go to pasco.com/wireless. Thank you.
See you next time.